Hello. Okay, let's go now to 33. You blow across the mouths of identical bottles A, B, and C, each containing different amounts of water, as shown. From highest to lowest, strike the pitch of sound for each. Now remember, in this, as when you blow across the top, what is going to be vibrating is the air in the bottle. So the highest pitch will be the one with the least air in the bottle, and that would be A, or glass. S. The next one will be C, E, and the last one will be B, E. So it will be A, C, B, E. But if you tapped it instead, it would be just the opposite, because what will be vibrating is the water and the glass, and the one with the most mass would have the lowest, and the one with the least would be the most. So it would just be opposite. But for blowing across the top, what you're agitating is the air. So the one with the least amount of air will be it. The answer to this one is U, as in umbrella. 34. Your friend says that frequency is the quantitative measure of pitch. Do you agree or disagree? And quantitative means that's something you can measure. You can measure the frequency, so that you should agree on. Pitch is a qualitative one, while quantitative is something you can measure. So the answer is you should agree, and the answer here for this one is I, as in England, or ink. 35. As pitch of a sound gets higher, what happens to the frequency? Since pitch is how we perceive the frequency, for us to perceive a higher frequency, the frequency must have actually gone up. And the answer for this one is O, as an object. 36. Your classmate says that timbre refers to the quality of a steady sound composed of a mixture of harmonics of different intensities. Do you agree or disagree? You should indeed agree, for that is correct. And the answer for this one is B, as in banker. All right, 37. And why should guitars be played off stage before they're brought on stage? Think thermally. Well, basically, as the strings of the guitar warms up, they expand. That changes their tension, so their frequency will actually decrease. So when you play it off stage, you're trying to warm up your instruments to the temperature that they will be operating at on stage. To avoid changes of the tuning. And the answer for this is L, like in lumber. So 38. If a sound becomes louder, which wave characteristic is most likely increasing? And basically that would be amplitude. And the answer to this one is N, as in new. 39. Explain how you can lower the pitch of a note on the guitar by altering the strings A length. So If you lengthen it, you will lower it because it has more mass. If you loosen it, you lower the tension, that would lower the pitch. And C, thickness or mass, and you increase the mass by making it thicker, that will lower the pitch. And the answer here is Y. 40. Does the pitch of a note depend on sound frequency, loudness, quality, or all of these? The pitch depends only on the frequency and how you perceive it. But of the choices, it would be frequency. And the answer here is W, as in window. So 41. When a guitar string is struck, a standing wave is produced, causing a sounding board to oscillate with a large sustained amplitude, pushing back and forth against the surrounding air to generate sound. How does the frequency of the resulting sound compare to the frequency of the standing wave in the string? Again, and when a wave is created, the frequency of the wave matches the source of that wave. And in this case, as the source was the standing wave in the string, so they would have the same. The answer here is E, as in everybody. 42. The strings on a harp are of different lengths and produce different notes. How are different notes produced on a guitar while the strings have the same length? Well, their tensions vary and their thicknesses vary. So that's how they produce different notes, plus the fact that as you place your hand on them, you can also alter the length of it. And the answer to this is Q, as in quality. 43. If a vibrating string is made shorter by holding a finger on it, what effect does this have on the frequency of vibration or pitch? By doing this, you are actually reducing the wavelength of the vibrating string, and thus the frequency will increase. So you have an increased pitch. So that is R for real. A nylon guitar string vibrates in a standing wave pattern as shown below. What's the wavelength of the wave? And the wavelength will simply be from here to here, or 60. And the answer for this one will be A, as an apple. Why do tuning forks with long tines vibrate at a lower frequency than short tine tuning forks? Having a longer tine, they're longer, has more mass. More mass makes it harder for it to vibrate, so it'll vibrate at a lower frequency. And the answer for this one is C, as in cat. Why are bass strings of a guitar thicker than treble strings? And the greater mass of the produces a lower frequency, and thus a deeper sound. And that's why they have to be thicker. And the answer to this is appropriately G, as in guitar. 47. Will the thicker or thinner of two guitar strings of the same tension and length vibrate at a higher frequency? Since they have the same tension and length, the only difference is thicker or thinner, so the thinner one will have less mass, therefore it'll be at the higher frequency. And the answer here is L for length. 48. Why doesn't a vibrating guitar string sound as loud when it's mounted on a workbench as it does when it's mounted on a guitar? On the guitar, it has a sounding board, which also vibrates, which increases the amount of air molecules moving and thus increases the sound. But while it's on the workbench, it just a little bit of the string that's vibrating, so it doesn't produce nearly as much sound. So that will be the answer to this one is P as in plug. 49. Would a plucked guitar string vibrate for a longer time or a shorter time if the instrument had no sounding board? Well, in vibrating the sounding board, energy is being taken from the string to the sounding board. So it will not go as long with the sounding board. So if there is no sounding board, then it would be for a longer time. And the answer here is S for simple. 50. If you very lightly touch a vibrating string, guitar string, at its midpoint, you'll hear a note that is 1 octave above the frequency for that note. Octave is a factor of 2. So it'll double the, basically you go to the second harmonic. The first harmonic is like this. The second harmonic is here. They're both happening at the same time, but if you put your finger here, you'll dampen that out, leaving only the second harmonic going, and that's why it will be 1 octave above. And that is 50. The answer is V for victory. 51. If a guitar string vibrates in 2 segments, where can a tiny piece of folded paper be supported like flying off? Well, that would be at the nodes. And how many pieces of paper could be similarly, folded paper could be similarly supported waveform that has 3 segments? And so if you have 3 segments, so 1, 2, 3, 1, 2, 3. So at the node you could do it here, 1 and here. So the answer is 4. And the answer on the homework quiz will be Y as in yes. Why do the same notes played on a trumpet and a saxophone sound different when they're played at the same pitch and loudness? It again deals with the quality, on the number of harmonics and their relative intensities. And the answer here is Z for zebra. The amplitude of a transverse wave in a stretched string is maximum displacement of the string from its equilibrium position. How does the amplitude of a longitudinal sound wave in air correspond to? Then that deals with the pressure. When you have the compression, a zone, the pressure goes up. When you have a rarefaction, the pressure goes down. So it's the variation of pressure. And the answer here is B. I did not want